In our class My Linked List, we're going to incorporate print. We have discussed print in the past somehow when we were declaring the class node. If you remember the class node, we have to use a temporary variable node in order to make sure we point to the first value, and then we move all the way till we hit the null. We move by using the dot next, which is the connection between nodes. When we hit the null, then that will be an indicator that we finish our connection. We're going to do something similar here, but this time we're going to create a method called print. I want you to pay attention on the following item. Print, it's a void method. It's public because that is the only interface that we're declaring in our class name. Remember that the print is only an operation that we're going to use. So therefore, internally, we're going to invoke a call method print with a reference of the first. We need a placeholder when we need to start. That's why first will be the indicator to navigate through the list. Therefore, we need a private method. Very similar signature. This time it will take a value. Let's call it n for the node. Now we're going to do, as long as the n doesn't hit the null, what we're planning to do here is to do a system out print the value n dot data, and we can just concatenate with some space. I usually put a tab to make it more space. The way we're going to update our node n is by going to the dot next. Very similar to what we did when we're dealing with nodes. When we're done, print line, a new line, let's go to the tester. After adding the elements that you see here, after the is empty, I would like to just print what is in the list. Notice that the print that we're invoking on line 11 corresponds to the method defined on line 22 without any parameters. Internally, this will invoke print, the private method, and will pass internally the reference of first, which is the node. Remember that first is one of the two fields that we declare at the very beginning of the class linked list. Let's go to my linked list. Let's save, compile, and run this program. As you can see here, we're printing the elements separated by tabs. This is a funky weird tab here because of the spacing that we got, but we're printed there. Now, since a linked list is a natural recursive data structure, might as well we can define the print as a recursive. Let us define the method print node n, but we'll implement this recursively. I'm going to exercise those algorithms in order to translate an iterative method. We know that we're going to continue doing this as long as we don't hit the null. Might as well put an if statement. As long as the value that you provide here doesn't hit the null, you will do printing and then invoke yourself after that. Therefore, this is your recursive call. The only difference is that we're going to call inside of the method print as that next. Now, this is as long as you don't hit the null. It will be necessary to have a base case. I comment out the iterative one just for this testing purposes. I'm going to leave it there for your reference. But in reality, this interface didn't change anything from the main. As a matter of fact, we haven't touched the main. The only thing that we're changing here is the implementation of the print method, the private method. Let's go back, save, and compile this program. Same output. This time we use a recursive. In order to make this distinction, it's almost impossible. Only you know because you have access to the private method. I'm starting to dislike the tab for this point. I'm going to put a space here. Let's save, compile, and run this program only to see what's going to happen in the output. There we go. You can see now we have hello space computer space science space EPCC.